The VAST catalog is something that is built into the VAST database, or sorry, built into the VAST cluster for this. So, kind of the problem that you have, especially when we start talking about large data sets or large arrays or a lot of information, is that how do you determine where your data is? Who's using the space in your system? How is it indexed? Where are the files located? What types of files do you have out there? For a small data set, not such a big deal. But when you start talking about 10 different NFS exports, 100 different NFS exports, 100 S3 buckets, SMB shares, NFS shares, S3 buckets, billions upon billions of files with different owners and different access rights, maybe connected to different networks, it becomes very, very complex to go through and get a good view as to what you have on your system. You have to go through and maybe write some find commands, but a find might work on an FS, but you need to write something different for SMB, or you need to query things for S3 buckets, that maybe you do or don't have access to. So what the VAST catalog does is that it simplifies a lot of this. The VAST catalog at its core is basically it's an index of the metadata of all the files and objects on the cluster. So we go through, we take a look at the metadata, we snapshot the metadata of it. That includes things like ownership and size and permissions and S3 tags and location within the element store. And we'll take all of that and put this into a database that you can then go through and query via SQL or other methods to go through and get this information. It's something that, again, is internal to the VAST cluster. It does use the VAST database mechanisms that are there, but it is internal to the VAST cluster. It's something that's there without any additional charge. It's part of the platform itself. And this allows you to go through and write, some relatively complex queries. Like say, I want to find all the files or all the objects that are larger than 90 days, or that are older than 90 days and are larger than 10 gigabytes, which are in this particular directory. Or, find all the files created last week by a specific user, or look at rate of change in a directory. For that. Or let's say I want to find all the files that are out there, all the S3 objects that have a tag that's a process tag, meaning you've indicated that some work has been done on those. You can also go through and do things like capacity reporting on this. Now, capacity reporting is going to be separate from things like quota reports, because with quota reports, you have to set a quota on certain things. This will go through and encompass everything that's on the cluster itself, even if you haven't explicitly called for it or you're tracking it otherwise for that. So, we can go through and also, do things like, we'll look at the file extension and rank files like that, or things like that. So it's a very, very powerful tool to go through and use. So again, how does this work? How do we accomplish this? Well, part of the mechanism here is that we leverage snapshotting internally. And actually, we leverage snapshotting and the replication engines that we already have within the cluster. And the snapshotting will go through, and at the base level, if we don't want to, we can either snapshot the metadata, which we store in our SCM for that, or we can also optionally include all the data of this as well, such that when we take these snapshots, if we want to actually look at the data rather than just the metadata, we have a record of that too. We can go through and access that if we choose to do so. But effectively, we'll go through, we'll take a snapshot of the metadata, and then we will load that into a database table, which can then be queried. This will happen on a periodic basis. You can set it, up to once every 15 seconds to go through and do that. For that, you can store as much history as you want to control change, subject to space limitations with that. But you can go through and control that. Now, within the database itself, we'll have one row per object. For that, and the metadata, any metadata of interest, such as some examples here. Who is the owner? What is the UID of that file? Who is the group owner? What's location, access time, modification time, things like that. Those will be stored as columns. So we can query on any one of those. If we have S3 tags, we can actually query based on S3 tags or other metadata tags or other metadata information within this too. For S3 tags, we can either store it as a single column or a complex object within a single column, or we can optionally call those out and index based on those tags as well. So it's very, very powerful to go through and do so.